Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, I know that all of you are eagerly awaiting to learn the further concepts in the chapter number system. Okay, then let us not waste our time. Let us continue the chapter number systems. Then what are you thinking? Yes, boost your mind by recalling yesterday's concepts. Dear students, yesterday we learned how to represent some numbers on the number line, whether it may be rational or irrational, and we learned how to classify the given numbers as rational and irrational. And third important point is we learned how to write the number of irrationals between two given rational numbers. Then fourth important point is if the decimal number is given, we can express that in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay, now we are moving to the new concept. It is also very interesting one. Then that concept is we are going to represent the real number, particularly the decimal, whether it may be terminating or non-terminating on the number line. Got it? Then for that we go for using a method. Do you know what is that method? Just before that, just let me give you one simple information. Assume that you are holding a transparent material and you are bringing the transparent material close to the notebook. Then the letters in the notebook will start becoming bigger and bigger and bigger. Then can you tell what is that material? Yes, you are right. It is magnifying glass, magnifying lens, nothing but convex lens. What happens if this convex lens is kept on the number line? Just observe it. This is the number line, and here it is 0, 1, and this is 2, this is 3. You are going to place the magnifying glass on the number line. Then which numbers will appear bigger? 0, 3 or 1 and 2? Only 1 and 2. 1 and 2. Then and these will get split up as 1.0, 1.1, 1.2, 1.3 and so on. Like this, we will go for representing the decimal numbers on the number line using the magnifying glass, and this process is known as successive magnification. Once I repeat, successive magnification. Definition is the method of representing real number, nothing but decimal number on the number line by using magnifying glass is called successive magnification. So now let me go for writing the definition. Yes, dear students, observe here. I have written the heading representing real numbers on the number line. So you have to write this later. Now, without fail, you have to listen my words carefully. The method that we are going to use to represent the decimal numbers, particularly decimal numbers on the number line, it is successive magnification. I told you the definition. The process of visualization of representation of number on the number line through a magnifying glass is called successive magnification. Simply, if you want to write that in your own words, the method of representing the decimal numbers on the number line by using the magnifying glass is called successive magnification. Got it? Now, if the magnifying glass is used on the number line, see that how it looks. See that here, this is the part of the number line which can be seen through magnifying glass. See, it looks bigger than the rest part of the number line. Then how to represent the decimal numbers on the number line? Here I have taken one example, 2.125. Could you tell what type of decimal expansion it is? It is terminating, right? So here after decimal we have 3 digits. No problem at all, it can be represented on the number line. But what about this? This is a number and a decimal number, and it is non-terminating, recurring. non-terminating, recurring. Here so many digits will be there in the decimal expansion. How to represent it? Under such condition, we go for using the concept that it should be represented up to 2 decimal places, 3 decimal places, 4 decimal places, like this. For example, here 3.142857 is there. What is? Up to 4 decimal places. Up to 4 decimal places means we will take 3.1428. Up to 2 decimal places, 3.142. Up to 2 decimal places, 3.14, like this. Did you understand? Okay. Now, let's move on to worked examples that are given in the textbook. The first one, question will be asked like this. Visualize the following numbers on the number line using successive magnification. Just one example I have taken, which is simple one. 2.67. What type of decimal expansion it is? Yes, you are right. It is terminating. Let us come to know how to represent it on the number line. So before that, during the representation, you have to identify the given number lies between which 2 whole numbers. See, 2.67. It is more than 2 and less than 3. Hence, I write this as, so 2.67 lies between 2 and 3. So first I go for drawing the number line, in which only the positive integers, nothing but natural numbers are taken. This is, here I have drawn a number line, and here I have marked for every 1 centimeter. If more space is there in your notebook, you can take 1 unit as 1.5 centimeter, 1.5, 1.5, 1.5, like that. 10 parts are there. Here, why you all may be thinking that why I have drawn 3 number lines. Yes, I tell you the reason. You just count the number of digits in the decimal part. If 2 are given, then you have to add 1 more. So total 3 lines. If 3 digits are given in the decimal part, you have to take 4 lines, like this. Okay, observe it. And these lines should be parallel, and the point should be collinear, like this, in vertical also. Here this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Just I am going to extend it. 10. Got it? These are the natural numbers. We know that the given decimal number lies between 2 and 3. See, I am going to select the point which represent 2 and 3. So 2.67 lies between these two. So now I am going to enlarge it by using magnifying glass. I draw that magnifying glass later. Just observe it. When we expand 2 and 3, see, 2 to this initial point and 3 to this initial point. Here you can see that. Up to here. Now, which point it is? It is 2. So, between 2 and 3, again, some divisions will be there. I am going to write them also. It is 2.0. This is 3.0. Between them, this point is 2.1. This point is 2.2. This point 2.3. This is 2.4. This is 2.5. This is 2.6. It is 2.7, 2.8, 2.9. To make you to see the points clearly, just I am giving additional markings so that it appears clear. Next, but see that number 2.67 is to be represented. Now just we are come to know it lies between 2 and 3. Now 2.67 Now you go for taking the digit in the decimal place. 2.67 lies between 2.6, then next number 2.7. So 2.6 is here, 2.7 here. I am going to take these two. From this point to 2.6 to initial point. This is 2.60. Next, here 2.70. This point 2.70. Now between these, again some divisions are there. Let us go for writing them. Here, this is 2.61. This is 2.62. This is 2.63. 2.64. This point is 2.65. This is 2.67. 2.66. This is 2.67. 2.68. This is 2.69. Got it? But which number we are going to represent it on the number line? Yes, it is 2.67. I am going to take that part. See, I am highlighting it. This is the point which we have represented on the number line. I hope that you all have understood. Using magnifying glass. So now I am going to draw magnifying glass. See that first the number lies between 2 and 3. I am drawing the magnifying glass. So you have to use compasses to draw the circle. Then 2 and 3, they are expanded as 2.1, 2.2, 2.3 and so on. Then 2.67 lies between 2.60, 2.70. So here I will take. Again I draw one more magnifying glass. This is. Next 2.6 and 2.7. Again they are expanded. We have got 2.67. Just I am highlighting this. Without fail, here you have to write. This is magnifying glass. So this is the method of representing decimal number on the number line. Clear? Okay. Now please take scale and pencil as well as compasses and go for writing from here. You have to copy from here to here. Now you will pause the video. Yes. Now just observe it. Second one. Here we have taken the decimal number 4.26 bar. Bar is applicable to both up to 4 decimal places. Could you tell what type of decimal expansion it is? Yes, you are right. It is non-terminating recurring. What is the recurring part? It is 26. That is repeating block. Up to 4 decimal places. So I can write 26, 26, 26, 26 and so on. But we want only 4 digits in the decimal part. This is the number which we are going to represent on the number line is 4.2626. Now first we have to identify between which 2 whole numbers it lies. Could you tell? Yeah, it is 4.2626. It is more than 4 and less than 5. Hence I write the number 4.2626 lies between 4 and 5. So now I'll go for writing the number line first. It is, see that. And one more thing you must remember, in the decimal part how many digits are there? 4. Then how many number lines we have to draw? Yes, it is 5. 1, 2, 3, 4, 5. 5 are there. Now first number line, that is whole number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now the given number lies between 4 and 5. So we have to expand 4 and 5. So we must use magnifying glass. What do you call that method? It is successive method. representation of successive magnification. Here I'll write by successive magnification. So here I don't have much space to show that, hence I have drawn all the number lies there only. Between 4 and 5 the given number lies, hence let us go for expanding it. So here 4.0, here 5.0. Then you have to take a scale from 4 up to this initial point. Then from 5 up to this terminating point. Got it? Now here I'll write the numbers 4.0, this point 4.1, this point 4.2, this point 4.3, this is 4.4, it is 4.5, this is 4.6, this is 4.7, it is 4.8, and this is 4.9. I hope that you all have understood this one. Next, you take first digit in the decimal part, 4.2. So this number lies between 4.2 and 4.3. This is 4.2 and 4.3. I am going to take these 2 points, and these 2 points should be expanded. So here 4.20, here 4.30. Now let us draw the line from initial point to 4.2 and next one, final point to 4.3 or 4.3 to final point, 4.3 to final point. When you are drawing, better to use the long scale, it comes correctly. Now let us write the numbers. It is 4.20, this will be 4.21, this is 4.22, it is 4.23, this is 4.24, it is 4.25, this is 4.26, this is 4.27, this is 4.28, this is 4.29. Now you go for taking second digit. See, next 4.26. So the given number lies between 4.26 and 4.27. So 4.26 and 4.27. I'll choose these two, and here I'll write 4.260. Here 4.270. Got it? Now you can no rule that you have to write the numbers horizontally. Even you can go for writing vertically, because space between 2 points will be less. That is why I told you, if possible, see that notebook and based on that go for taking the scale. It is better to take 1.5 centimeter as 1 unit. See this distance 1.5, 1.5, 1.5 like that. So you feel more comfortable to write the numbers. So 4.26 is here. I draw the line from initial point to 4.26. 4.26. Then and 4.7 to terminating point. Now I'll write the numbers from here. 4.261 here. 4.261. This is 4.262. Then we feel more comfortable for writing the numbers. It is 4.263. It is 4.264. This point 4.265. This is 4.266. This is 4.267. This point is 4.268. It is 4.269. Got it? Next, let us go for taking another digit. That is third digit. It is 2. 4.262. Then another one 4.263. 4.262 and 4.263 from this point. Here I'll write 4.2620. Then 4.262 Clear? Here I'll write 4.2620. Then 4.2630. Draw the line from here. To this terminating point. Now I'll go for writing the decimals. 4.2620. This is 4.2621. This is 4.2622. 4.2623. This is 4.2624. 4.2625. 4.2626. This is 4.2627. This is 4.2628. This is 4.2629. And this is 4.2630. What is the given number? It is 4.2626. Here, where it is? Here, 4.2626. I am highlighting this with the box. Clear? So to represent the number, we have used magnifying glass. Hence, I go for drawing the magnifying glass. Here first we have taken the enlarged part of 4 and 5. Then we have got these decimal numbers. Here, again the magnifying glass. Here is magnifying glass. Please use the compasses to draw the circle. It comes neat. This is the handle. Got it? So this is the method of representing the decimal number. Non-terminating recurring decimal number up to 4 decimal places on the number line. Once I repeat, here in the decimal part we have 4 digits, hence we have taken 5 number line. If 2 digits, you have to take 3 lines. If 5 digits, you have to take 6 lines. Clear? So you need patience to draw these number lines. Now you have to copy from here. With patience, you have to write up to here. Yes, copy. Bye. Okay, dear students. Next, with respect to successive magnification only, we have 2 more problems in exercise 1.4. I have written both of them. See, the first question, just observe, don't go for writing now. Visualize on the number line using successive magnification. The number is 3.765. If you want what type of decimal expansion it is terminating, because it has countable number of digits. Then could you tell how many number lines you are going to draw? Yes, you have to draw 4 number lines. Why? Because in the decimal part we have 3 digits plus 1, 4. So 4 number lines. And second one, just we came to know that is 4.2626. It has been already represented on the number line. Now third one, just it is additional. The question is, visualize the representation of 5.37 bar. Here bar is applicable only for 7. On the number line up to 5 decimal places using successive magnification. Now 5.37 bar is there. How do you write this? It can be written as 5.37777, and there is no end at all. Now, here they are given up to 5 decimal places. That means you have to take 3, 7, 7, 7 and 7. You can write 5.37777 4 times. It is up to 5 decimal places. Then how many number lines should be drawn? Yes, you are right. There must be 6 number lines. Why? Here 5 digits are there in the decimal part plus 1. So 6 number lines. Got it? So you have to do that in your notebook. Got it? Please continue this one. Now pausing the video, go for we are representing these numbers on the number line. Now we will move on to the next concept. Okay. Dear students, I think you might have finished that. That is exercise number. What is that? It is 1.4. You've completed. Now look here. Now we are moving to another interesting representation on the number line. Observe this. So far we have learned how to represent natural numbers on the number line, whole numbers on the number line, then integers on the number line, and irrational numbers like root 5, rational numbers like 2 by 3 and so on. But this is somewhat bit different. Observe. Heading is representing square root of x on the number line where x is given positive real number. That positive real number is in the form of decimal. It may be 2.5, 4.5, then 5.7, 9.8, like that. Such numbers will be taken. And the question will be asked in the examination like this. Represent square root of 5.7 on the number line geometrically. Geometrically means you are going to use the geometrical instruments. Next, also give justification with calculation. That is, after locating that point, how that point represents square root of 5.7. That should be explained with the calculation. Okay, now let us go for learning. It is a very important concept in the examination point of view. I am going to put star mark for this. Then how to locate this? Let me tell you. Just do follow the procedure what I am going to do that one. Observe. Represent square root of 5.7. According to geometrical method, we will go for drawing a straight line. Here I draw. Let us draw a straight line. How much length? Let it be 10 centimeter, 15 centimeter. It's left to you. See that notebook and draw according to that. Next, here 5.7 is there. Now, we have to mark a point to 5.7. Here, I just go for using the scale. This is 0. Now, here in my scale, I am taking every 10 centimeter as 1 unit. 1 unit, 2, 3, 4, 5, 50, 57. 5.7. This is. You call this point as A. And this point as B. What is the distance from A to B? It is 5.7. 5.7 centimeter. This is the distance from A to B. Then after that, we have to take 1 more centimeter additional. 1 more centimeter. 1. And you can go for taking number of points also. Let me tell you why in the later part of this calculation. So we want only 1 point. Call this point as C. What is the distance from B to C? It is 1 centimeter. Clear? The given number is square root of 5.7. First, we have marked the point A. Then we have marked the point B to a distance of 5.7 centimeter. Then we have marked another point C at a distance of 1 centimeter from B. Understood? Okay. Now, you have to use the compasses. Then mark the midpoint of AC. If it is just 10 centimeter, we can mark it for 5 centimeter. If it is 11 centimeter, 5.5. But here, what is the length from A to C? 5.7 plus 1, 6.7, midpoint. So that is why we need to use compasses. So with A as center, To mark the midpoint of AC, you have to draw perpendicular bisector to AC. Now, with A as center, you have to take more than half of AC. Here I am taking more than half of AC. You just draw an arc and here also. Next, with the same radius, with C as center, draw another arc which cuts the first previous arc. Next, it cuts second previous arc. Got it? Next, join these 2 points with the dotted line. It is an imaginary line, or just you can mark only 1 point here and you call that point of intersection as O. Next, again you have to use the compasses with O as center and AO as radius. You have to draw a semicircle. Here I will draw that. With O as center, AO as radius. AO as radius, we have to draw a semicircle. Then after that, at B, draw a perpendicular. For perpendicular, you can go for using protractor. See, this is the protractor at B. Mark, so keep the midpoint of protractor at B. Mark against 90 degree. You may go for using even a set square, that is triangular shaped scale as well. From point B, draw a perpendicular. It intersects the arc at point D. Understood? And we call the length of BD as square root of 5.7. Then you all may be thinking that how this is possible to say length of BD is square root of 5.7. First I go for calculation, then we will continue this one. Here I will write in calculation part. Observe this. Here, what do you call AC with respect to this semicircle? AC is the diameter, right? Okay. AC is the diameter. What is the length of AC? A to B plus B to C. I can write AC equal to AB plus BC. It is nothing but 5.7 plus 1 centimeter is equal to 6.7 centimeter. Clear? Next, then what is the length of OD? Why should we take the length of OD? The reason is you are going to find out the length of BD. On joining OD, you will get a triangle, that is right triangle. Then if it is a right triangle, then you can go for using a theorem called Pythagoras theorem. To find out any one side, other two sides must be known. You are going to find out BD, hence we need to know OD and OB. Then what do you call OD? It is with respect to semicircle is radius. OA, that is also radius. OC is also radius. I write AO, CO and DO. All these are radius. Then what is the length of this radius? Already diameter is known. It is 6.7. Radius is half of the diameter. So 6.7 by 2 centimeter. Here I write D equal to 2R. In a circle, the diameter is twice of radius. Our radius is half of diameter. We have taken this one. Next, we got the length OD, right? Next, we want OB. How do you find out the length OB? See that? What do you call from O to C? This is the radius. In this radius, when you subtract 1 unit, you will get OB, right? Here I write OB is equal to OC minus BC. OC minus BC. Then what is OC? OC is the radius, that is 6.7 by 2 minus BC, it is 1 unit. It is equal to, you may go for simplifying it. LCM is 2, 6.7, multiply LCM with second term, minus 2. It will be 6.7 minus 2, it is 4.7 by 2. I hope that you all have understood this. Next, we got length of OD, length of OB. Then you can go for finding BD by using Pythagoras theorem. I go for taking the triangle OBD. In triangle OBD, angle OBD is equal to 90 degree. Now, by Pythagoras theorem, you can write the square of hypotenuse, that is OD square is equal to the sum of squares of other two sides, that is OB square plus BD square. OB square plus BD square. Then what is OD? That we have already written. OD is 6.7 by 2 whole square. Then what is OB? Just we have calculated, it is 4.7 by 2 whole square plus BD square, it is unknown. Next, transfer 4.7 by 2 whole square to the left hand side. Now here I write 6.7 by 2 whole square as it is minus 4.7 by 2 whole square. It's equal to the remaining BD square. If you go for using square of these numbers, you may find it difficult. That is why. Then what can be done? You can just go for using your previous year concept. See that here a square term minus another square term. Then do you think that it is in the form of an identity? Yes. What is that identity? It is a square minus b square. Then what is a square minus b square? You are right. It is a plus b into a minus b. I will write these two terms in this form. A plus b into a minus b. 6.7 by 2 plus 4.7 by 2 into 6.7 by 2 minus 4.7 by 2. It is equal to BD square. Now, denominator terms are same. You can go for simplifying the numerator easily. Now, denominator is 2. I go for adding these two. 6.7 plus 4.7. Because repeatedly I have been telling, when in fractions, when the denominator terms are same, you can write the numerator terms as it is. Now 6.7 plus 4.7. 6.7 plus 4.7. You can add it directly. Then here denominator LCM will be same. 6.7 minus 4.7. I go for writing this here. Next, what is 6.7 plus 4.7? You just go for adding them. You will get 6 plus 4, 10. Then 0.7, 0.7, 1.4. So it is 11.4. 11.4 divided by 2. Here I write. It is BD square is equal to 11.4 by 2. Then what is 6.7 minus 4.7? Subtract. You will get 2 by 2 as it is. 2 get cancelled. Then 1 will remain. 1 into 11.4 by 2. It is 11.4 by 2 only. Then divide this. 2 5s are 10. 1 will remain. It becomes 14. 2 7s are. So BD equal to BD square equal to 5.7. Then BD equal to square root of 5.7. Then do you agree that the length of BD is square root of 5.7? Yes, square root of 5.7. Now, this length should be represented on the number line. Now, Again we have to use the compasses. Take a distance of BD and draw an arc. See, with B as center, it is very important. With B as center, BD as radius, draw an arc which cuts the number line at a point and call this point as E. So this point is square root of 5.7. Then you all may be thinking that, sir, of course, we have located square root of 5.7 on the number line. Between which two values it lies? How can we come to know on the number line? There are no numbers on this number line. Yes, I'll give you justification for your question or your thinking that here, just for the sake of information, I am writing here square root of 5.7. Could you tell between which two perfect square 5.7 lies? Previous number is 4 and the next number is 9. Square root of 4 and square root of 9. Then what is square root of 4? It is 2. Square root of 9? It is 3. Then square root of 5.7. It lies between 2 and 3. Then how can, there is no numbers only. Yes, you are right. Hence now I am going to write the numbers. Observe. This point, in this number line, you have to take the point B as 0 and point C as 1. This point as 2 and this point which is marked as 3 and one more point, this is 4. Now you can come to know that square root of 5.7 lies between 2 and 3. Here I'll write conclusion. Therefore, E represents square root of 5.7. Got it? I hope you all have understood. Okay, before going to just copy, now once I tell how to follow this one. Here, this is geometrical representation. By geometrical representation, let me tell you, listen carefully. First you go for drawing a straight line, correct? Then you mark the point A from here. Mark the point B at a distance of 5.7. Here whatever the number will be there inside the root, that should be marked. 5.7, here 5.7 plus 1 centimeter. Mark this point as C. 5.7 plus 1. Okay. Next, you have to mark the midpoint of AC. So you have to draw the perpendicular bisector, which you have already learnt in your previous class. With A as center, in compasses you have to take the distance more than half of AC. Then draw the two arcs with the same radius with C as center. With C as center, draw the arcs which cut previous arcs and join them with a dotted line and mark the point O. This is the midpoint of AC or midpoint. Next, again you have to use the compasses with O as center, AO as radius or CO as radius. You have to draw a semicircle. Clear? Next, after that, at point B, draw a perpendicular. First, use the protractor, mark against 90 degree, take a scale and draw a perpendicular which cuts the semicircle at a point. Call this point as D. Now, BD is square root of 5.7. Clear? Next, with B as center, BD as radius, draw an arc which represents, it cuts the number line at a point. This point is E. This is the point E which represents square root of 5.7. Clear? If you want to know the value between which the square root of 5.7 lies, you can go for marking this. It is called B as 0, then C as 1, next point. This is every 1 unit. Then 2, next 3, next 4 and so on. You will get it lies between 2 and 3. Next, there is a chance of giving justification in the examination. So we have shown that with the calculation. Once I repeat that calculation, go through this carefully. So first we have to join OD. That should be written. Join OD. After that, with a dotted line only. After that, we use Pythagoras property to find out the length of BD. To find out the length of BD, you must know OB as well as OD. Hence, first we have taken AC, which is the diameter of the semicircle, and half of diameter is radius. See that OD is radius, OA is radius, OC is also radius. Now diameter is 5.7 plus 1, total 6.7. The radius OD is half of the diameter, that is 6.7 by 2. Next, we want OB. See that O to C, it is the radius. But OB is a part of that radius. When you subtract this 1 unit in radius, you will get OB. So we have written OB equal to OC minus BC. OC, that is the radius 6.7 by 2 minus 1. Then taking LCM and simplifying, you will get 4.7 by 2. Now we got both the sides OB and OD. Go for using Pythagoras property. Square on hypotenuse is equal to sum of squares of other two sides. Then substitute. Here is very important. Don't go for applying the square to both the terms, numerator and denominator. Instead, use identity. You find it very easier. Now, here on transferring, we have got this statement. It is in the form of a square minus b square. It is expanded a plus b into a minus b. Then it has been simplified by taking LCM. Then after that, BD square. On adding these two, you will get 11.4 by 2, and subtracting, you will get 2. 2 by 2 you get cancelled. 11.4 by 2. Again, on cancelling, you will get 5.7. BD square equal to 5.7. BD equal to square root of 5.7. Got it? So please learn this. Please learn this, because it is very important in the examination point of view. In your school exam, 100% this type representation will be asked in the examination. Okay? And if you want to practice, you can pause the video and you can go for listening again and again. Okay, anyway. Now you have to pause the video and start writing from there to there and use geometrical instruments and represent like this. Yes, go for that. Okay, dear students, I think you might have completed this. Just one small assignment like this only. You have to represent square root of 9.8 on the number line. And after constructing, please send that to my WhatsApp. Got it? Okay. Now, before concluding the class, now just we shall go for some of the important points, some of the important problems what we have come across so far in this chapter. Total 6 periods are over. Now, here I have prepared a chart which includes some important questions which must be practiced in the examination point of view. Now, look here. The number system, that is the name of the chapter. Here, the very first question, it is, what is a rational number? And another one is an irrational number. This is one point. Second question is, we have to find out some rationals between given rationals. I have given natural numbers, then fractions, then with the fractions with the different denominators. Next, third question is, represent square root of root 5 on the number line. There are two methods. One is spiral method and second one is direct method. In direct, it may be horizontal or vertical. Then fourth question is also very important. Show that the following numbers in the form of P by Q. 100% this will be given in the examination. So these are the numbers. Got it? Next, fifth question. Fifth question is, find 3 irrational numbers on the number line. Irrational numbers between the rational numbers. I have represented them. Next, today we have learned that visualize the following on the number line by using successive magnification. Chances may give or may not give. And another one, seventh one is, as I said, it is very important, represent square root of 9.3 on the number line geometrically. Also verify, got it? That is, verify that length or showing the representation on the number line with calculation. And one more I have written, write the kind of decimal expansions. Clear? Okay. Now, okay, dear students, please do practice them. Okay, before concluding the class, one more thing I want to tell you. Dear students, you all know that tomorrow, that is June 21st, the whole world is going to celebrate International Yoga Day, right? So, we the Indians feel very proud because yoga has been originated from our country. And this yoga is very important and essential in our day-to-day life because it gives the physical health, mental health and also spiritual practice. So do practice yoga every day, at least 5 to 10 minutes with the guidance of your yoga teacher. So on the occasion of that World Yoga Day, International Yoga Day, on behalf of Pi Academy, I am wishing Happy International Yoga Day. Thank you.